This is Mr. Martin. In this video we are continuing with Chapter 7. In this video we're going to be talking about dilations. So it's going to be very similar to stuff that we've been talking about already, so it should just be an extension of what we've been talking about. But let's go ahead and take a look at what we've got going. A dilation is a transformation that produces an image that is the same shape as the original but is a different size. Okay, so this should match with what we've been looking at as far as similar figures. If figures are similar, again, they have the same shape and the same size. So we're just formalizing that the original and the new one are formed by a transformation called a dilation. So a dilation enlarges or reduces the original figure from the center of dilation by a scale factor. So again, all of this should look familiar so far. Okay. Angles and slopes. So we're going to introduce slopes back in. Of sides stay the same. And we'll take a look at this in an example. Lines stay parallel. Well, I'll mention this when we look at an example. The center of dilation is the only point that does not move in a dilation. Okay. So let's take a look at this first example. Quadrilateral ABCD was dilated to produce its image A prime, B prime, C prime, D prime. So make sure you look carefully at the picture because you'll see the original image has no primes by it. This point is in the same place for both, but we'll talk about that. And so here's ABCD, and you could see the new one has been shrunk down. So we can see ABCD is larger and A prime, B prime, C prime, D prime is smaller. So is the dilation an enlargement or a reduction? It is a reduction. And again, you have to look carefully and see where the prime is. So since the primes are here, it's smaller, it's a reduction. All right, what is the center of dilation and how do you know? So let me grab another highlighter here. So usually what we want to do is we want to draw a line that goes through a point and its image and then see where that goes through. So if I go through this point and through its image and keep going, I go this way. Now if I go through B and then go through B prime and keep going, it goes through this point down here at the bottom as well. And let's do the last thing for C and C prime. Okay, they all go through this point down here, so that's how you know what the center of dilation is. And in this case, since the center of dilation was one of the points of the original figure, then we only have these 3 lines, because if it's a quadrilateral, normally we would have 4 lines, and that's how we would see where the center of dilation is. Okay, so the center of dilation is D, and the reason that we know this is that the lines passing through each point and its image pass through D. All right, now we want to find the scale factor. So the scale factor is always going to be the image over the pre-image. Okay, so the image is what we end up with, and the pre-image is what we started with. So we need to look for a side from the image, so that's going to be our square root of 2. That's the square root of 2. And the side that it matches with is the square root of 18. Okay, and we can put this all under a single square root, so that's 2 square root of 2 over 18, which is the square root of 1 over 9 if I reduce it, and the square root of 1 is 1, and the square root of 9 is 3, so our scale factor is 1/3. So every original side has been shrunk down to 1/3 of what it was before. And then part D, the measure of angle B is 98 degrees. So we know that if figures are similar, and we know they're similar because the dilation produces a figure that is the same shape but not the same size, then this angle in the image has to be the same, so this has to be 98 degrees as well. Okay, so go ahead and finish up the rest of this. And when you have questions, let me know. You'll probably have some questions as you go through, and then we will see you in the next video.